Okay, so today we're going to talk about solving equations, kind of some techniques for solving equations that involve radicals. So what do you do? Okay, so phones up here real quick. If you haven't done that, earbuds away, please. So what do you think you're going to do, like in a problem like that? What do you suppose your strategy is going to be if I want to solve for x there?
You need to make the 5 not equal to the equation not equal to 5. Like get 5 out of there.
Well, okay, so I mean, like get it equal to 0. Well, normally we would want to do that if it were a polynomial, right? Okay, this one's a little different though. It's got that radical in there. Now just think in terms of what if I wanted to try to isolate that x? When I want to isolate the x, I've got to undo everything on the left side and get the x by itself, right? So what do you think I'm going to do first here? Yeah, maybe square it, right? I've got to undo that radical. Does that make sense? Okay, so we're going to talk more about that strategy. But first, we have to talk about what happens when we square both sides or cube both sides or whatever we need to do to undo a radical. Why don't you guys click the Chromebooks all the way closed? You got to see this or this one's going to elude you if you don't watch it. So there's something called the power rule. If both sides of an equation are raised to the same power, all the solutions of the original equation we'll still be able to find, but the problem is you're going to introduce maybe some other solutions to the new equation that aren't solutions of the equation you started off with, right? So here's a way to think about that. If the blue set here represents all the solutions of the original equation that involved radicals, when we square both sides or cube both sides, we expand the set of solutions to that new equation. So in addition to getting solutions to the equation we're trying to solve, we're going to get some new kind of false solutions. We call them extraneous solutions, right? So what's that mean? It just means this. This is the really important thing you have to always remember to do. You must check all your solutions in the original equation after you raise both sides to a power, because some of the solutions you get may be false. They might be extraneous. Okay, so here's kind of our checklist of things that we're going to do then. If we wanted to boil this down to like a recipe, what do we do? Well, we're going to isolate a radical in order to be able to undo it by squaring or cubing, right? Then we're going to raise, after we isolate a radical, we raise each side of the equation to whatever power we need to undo that radical. If it's a cube root, what do I have to do to both sides? To undo a cube root, what do you do? Cube both sides, right? If it's a fourth root, we take both sides to what power? How do you undo a fourth root? To the fourth power. If it's a square root, that's a second root, right? What do we do to both sides? Square both sides, right? So depending on the radical, that determines what power you raise both sides to. Okay, so then we take both sides to a power, and then we solve the equation. Now, we're not really going to deal with this other instance, but it's possible we could have multiple radicals in the equation. And if we did, we would undo one radical by squaring both sides, let's say. And then if there were still a radical in there somewhere, we'd have to isolate that other radical and do it again. We're not really going to go into that. Maybe we'll come back and I'll just show you a couple examples at some point of equations like that. But I'm not going to really have you focus on those. Once we're done, once we've taken both sides to a power and solved the equation, then the last step, which is very important, is we absolutely have to plug the solutions back into the original equation to see which ones are valid and which ones are extraneous or false. Okay, so let's go through those steps. Well, step 1, isolate the radical. Already done in this case, right? It's already by itself. So what's my next step?
Then you want to square them.
Square both sides. Okay, if I square both sides, squaring undoes the square root, so I just get 2x minus 1 on the left. On the right, 5 squared is 25. What are the last two steps here?
Then you just want to make it 0. Not mine.
In this case, what are we doing? This is just a regular old linear equation.
Add 1.
Add 1 and then Divide by 2. Yeah, good. And that's just going to give us 13, isn't it, if I do that? Okay, so we can't just assume that's correct, though. We have to plug that into the original equation and see what we get. So if we go back to the original radical equation and I plug in 13 for x, that gives me 2 times 13 minus 1, which is 25, under the radical. Well, is the square root of 25 equal to 5? Yeah, it is. So it worked. In this case, 13 is a valid solution. So 13 falls inside that blue set of solutions to our original equation. Okay? Let's try another one. How about one like this? What do I have to do first here?
Square.
Not yet. What was our first step? Let's look back again. What was our first step always?
Oh, yeah.
Isolate the radical. Okay, so how do I isolate that radical?
Add 1.
Add 1. I got to get the radical by itself on one side of the equation. So step 1, add 1 to both sides. Okay, now I isolated the radical. Now what do I do?
Now you want to square it.
Square both sides. Okay, if I do that, what do I get on the left side?
On the left side, you're gonna get x minus 1.
X minus 1, right? Because I just undid the radical. On the right side, 1 squared, well, that's just 1.
Dang.
So if I solve that for x, I get 2. What do I have to do now?
Plug it in.
Got to plug it in. Does that work? If I plug in 2, I'm going to get the square root of 2 minus 1 is 1, right? Is the square root of 1 minus 1 equal to 0? True or false? Yeah, it is. Right? So then, again, x equals 2 turned out to be a valid solution. Okay, that worked. All right, one more, and then I'll turn you guys loose on one here.
This one,
What do you think?
interesting. So basically, you don't want to put 2x and x. You want to find a way to get them together. You know what I'm saying?
No, let's just follow our rules. What was our first
Well,
rule?
You want to isolate it. Isolate the radical.
Isolate the radical. Okay, so let's see. So let's get somebody new contributing here. What's that look like? What's the one step to get that radical by itself?
I gotta clock out.
What do you think, Dylan?
Subtract 1.
I can't subtract 1 because look, the 1's inside the radical. I'm trying to get the radical by itself. So what do I need to get off of the left side?
Minus 2x.
Yeah, 2x. I got to subtract the 2x to the other side, right? Okay, so there's the first step. Subtract that 2x to the other side. We isolated the radical. What's next here? What are we going to do next? Once we isolate the radical, what's next? Square both sides. Sure. Okay, so if we square both sides, the left side is easy, right? Squaring just undoes the radical. I just get x plus 1. What about the right side, though? It's a little more complicated.
You want to distribute it out, but we have a pattern for this, which is a minus b.
Okay, good. We have a pattern. Nice. Now, you don't have to use it, though. I want to make the point here. Anytime you're squaring something like this, I'm multiplying it by itself. That's all squaring means, right? So we could just do this, and this is fine, right? We could just write this as 8 minus 2x times 8 minus 2x and FOIL it. That's no big deal, right? If I distribute the 8.
16.
No, what's 8 times 8?
64.
64. 8 times negative 2x. There you go, negative 16x. If I distribute the negative 2, negative 2x times 8 is another negative 16x. And now be careful with this one. Negative 2x times negative 2x is positive 4x squared. Good. Okay, and if I add all those things up, isn't that just 64 minus 32x plus 4x squared? That's fine. I can do it that way. Now, I would encourage you, the stronger you are as a math student, the more you're going to use patterns. That's not saying you can't do this, but eventually, if you go further in math, which hopefully y'all will, you're going to get to situations where when you take a quantity to a higher power, you definitely do not want to multiply it out, manually. You want to use a pattern because it's so much quicker. In this case, it's not that big a deal, but if this were cubed or to the 4th power, it is so much quicker to use a pattern. So in this case, the pattern is just this one that you know from the memorization test we did. The binomial, the quantity a minus b squared, fits the pattern a squared minus 2ab plus b squared. Well, what's a in this case? 8. Yes, this is my a right there. What's my b? Oh, darn it. Make that orange. There we go. Yeah, b is just 2x, right? B is what's being subtracted from A. So that would be my B. And then what do I get? If I go through the process of following this pattern, A squared would just be 8 squared. Well, there's my 64. Minus 2AB, minus 2 times 8 times 2x. What's that? 2 times 8 times 2x. Times 2. Right? 2 times 8 is 16 times 2x, 32x, right? So minus 32x. And then finally plus 2x, the quantity 2x squared. Well, that's just 4x squared, isn't it? Got to square the 2 and square the x. So you see how much faster it is to use that pattern. You don't have to do that whole FOIL process and combine like terms. You just get the answers directly when you use the pattern. All right, so now this takes us back to last unit. I've got a polynomial equation, right? I've got a bunch of terms. What do I do with a polynomial equation like this? Set it to 0, yeah. So everybody point, which direction should I push everything here? Yeah, to the right for sure, because I want a positive number of x squareds. So we're going to subtract x from both sides. And we're going to subtract 1 from both sides, so those guys cancel. And then that's just going to give us 63 minus 33x and plus 4x squared, right? And then that's all equal to 0, but let's flip it around so the 0's on the right. Just make it look a little more normal, right? Okay, so now we've got our polynomial equation in standard form where it's set equal to 0. Okay, this is the part we're all dreading, right? Now we've got to factor that thing if we can. I can't factor out a GCF. This is one of those harder kinds where I've got to find magic numbers and split the middle term and group. Okay, here's the good news. I'm not going to give you any like this on the test. In fact, I'm not even sure I give you any like that on the homework. And the reason is because soon we're going to have a better way of dealing with this. Next unit, after spring break, we're going to focus on solving just quadratic equations. And when we run into quadratic equations like this, we're not even going to waste time trying to factor that. We're just going to jump immediately to an easier technique, which would be using a formula, the quadratic formula, to solve that. Okay? But that's in the future. For now, just a quick reminder, because we want to remember how to do this. If I want to find magic numbers to split the middle term, what do they have to multiply to? How would I find out? Yeah, it's going to be the product of the outside coefficients. 4 times 63, that's 252, positive 252. What would they have to add to? Negative 33, good. And if we wanted to spend the time, we could find those numbers. They would be negative 21 and negative 12. They'd both have to be negative, and we could find them. They exist, negative 21 and negative 12. And then just a quick reminder, what do we do with those? Well, that's how we split that middle term, right? It's going to split into negative 21x plus negative 12x, and then we just factor by grouping. Group number 1, the GCF, the only thing we can factor out is an x. So we're left with 4x minus 21. Now we know we have to have the same binomial in group 2, and the only way to make that work is if I have a negative 3 out front. Okay, give me thumbs. That all makes sense? That's stuff from last unit. And we're going to be doing stuff like this for the rest of the year. So if you're feeling it all week on that, you got to go back and hit that review again, look at it a little bit, because that's important. The rest of the year we'll be doing things related to this. You know, polynomials are not going away. So now what? Okay, we got this thing, you know, we factored out the binomial from each group. That's common, so we'll undistribute that, and what's left behind? X plus negative 3, which is just x minus 3, right? And so we got it factored. Now we just apply the zero product property, right? I've got the product of two factors equal to 0. Well, when does that happen? The red factor is equal to 0 when x equals 3. That's easy. The right one, or sorry, the blue one, we'd have to do a little solving. We'd have to set 4x minus 21 equal to 0. And what would the two steps be to isolate x if I set that equal to 0? Add 21 to the other side, and then divide by 4, and I get 21/4. Okay, so those are my two solutions. We got to check those, but we don't want to be plugging 21/4 in and manually checking that. Do what I told you to do at the very start of the year that hopefully you've been doing all year. Use Desmos Scientific to check this. So remind me real quick, how does that work? How can I use Desmos Scientific, which is always available, to check this thing? What would I do? Yeah, I'm going to set f of x equal to the left side, and we would set g of x equal to the right side if we needed to, but the right side is just 8, right? So we just need to see if these values make the left side equal 8 also. So f of x equals 2x plus the square root of x plus 1. There's my function for the left side. And I'm going to plug in 21/4. That was one of my solutions. And does it equal 8? No, it equals 13, right? So is 21/4 a valid solution? Did it work? Give me thumbs. Up or down? When I plugged in 21/4 to make this equation true, what did it have to equal? It had to equal 8, but it didn't. It equaled 13. So when I plug in 21/4, I get 13 equals 8, which is false, right? So that is a false solution, an extraneous solution. Now I'll try the other one, yeah. And maybe it'll work, maybe it won't. If the other one fails, then there's no solutions, and that's a real possibility. That could be the case. F of 3, no, it gave us 8. So 3 worked. 3 was valid, 21/4 was extraneous. But there's really there could be no solutions. We could have had 2 valid solutions. In this case, we only had 1. So let's put this in our notes. Take a picture of this. Whoops. There it is. What did that do? Huh. That was kind of... There. Here, I'm going to move this thing. This is kind of in the way. So what happened then? X equals 3 was a solution that was inside the solution set of the original radical equation. X equals 21/4 was a solution of the new equation we got when we squared both sides, but not a solution of the original equation, so it's extraneous. Okay, so that tells us (13) is not equal to 8, so that one is false. Here, we got 8 equals 8, which is true. So x equals 3 is our solution. Okay, make sense? Okay. And there's kind of, just for the notes, there's, if we plugged in those values, what we ended up getting. True for 3, false for 21/4. Okay, you guys go try that one. Go to the boards and try that one. Okay, here we go. Quick, quick. I want to get you going. So what'd you do next?
All right.
Squared both sides.
Yep.
Okay, let's see. When you squared the left side, that just undid the square root. And we got 19 minus x. What'd you get when you squared out x plus 1 quantity squared?
You get x squared plus 2x plus 1.
Good. Okay, so now we're going to solve that equation, right? We're going to solve that. That's just a polynomial equation. That's last unit stuff. What do we do to solve a polynomial equation? Set it to 0. Good, so we want to move everything to the right side. So I subtract 19, I add x, and we get 0 equals x squared plus 3x minus 18. Now, how do we solve polynomial equations? We set them equal to 0, and then we factor, right? Okay.
So you're gonna get negative 3 and positive 6 for your magic numbers, or other way around. Actually, 6 and 3, but one of them's negative.
Right, we're going to get two factors, right? We're going to get x plus 6 and x minus 3, agreed? Because how come?
Because they have to multiply to negative 18
and add to 3. Okay, now when I have a basic trinomial where the coefficient of x squared is 1, those are easy. You don't have to split and group. You just set up the template. You know those have to be x's, and then you just try to determine, are there magic numbers that would make that work? Are there magic? Yeah, there are. Positive 6 and negative 3. Okay, now what? Well, we've got a product of factors equal to 0. Now's the 0 product property. The only way that the green factor and the pink factor can multiply to 0 is if you're multiplying by 0. That's the beauty of the 0 product property. Now we just have to ask ourselves, what are the solutions that would make that happen? What's the value of x that makes the green factor 0? Good. Or, yeah. So those are my solutions to the red equation, right? But we need to see if they work in the original equation up here, so we got to check them. All right, so what if we check negative 6? If x is negative 6, I get the square root of 19 minus negative 6 equals negative 6 plus 1. Is that true? Square root of 25 equals negative 5. No. True? No. That is not true. That's false. So what do we know? We know that one is extraneous, right? Cross it out. Doesn't work. Okay, let's try the other possibility. What if we try x equals 3? That gives us square root of 19 minus 3 equals 3 plus 1. Well, that's square root of 16 equals 4. True or false? True. So that tells us that this one is valid. That one checks out, right? X equals 3 is our only solution. Okay, give me 1 to 5. How are we doing? Is that making sense? Good. All right. Go to work. You got an assignment up there. This is the 8, what was this, 8.5?